Okay, this is web assign problem number 8 in universal gravitation. And in this problem, we have, here's we'll call this the surface of the Earth, and we want to know at what height above the surface of the Earth, this height here. The G field is a different value than it is here at the surface. And at the surface, I'm going to call this GA. And GA is given as 9.803 in the problem. We'll call this GB, G sub B, and that's a different value. And depending on what the value is, you could just make that equal to G M over R squared. Then you can solve for R. This whole thing along here, this entire distance from the Earth's center, we'll call R. And you can brute force it with big G, big M, solve for that, subtract off the radius of the Earth, and that would be H. And that's completely legitimate. However, it's kind of nice sometimes not to have to use this data that you don't necessarily have right at your fingertips. So, what we can do instead is put this into a ratio. So let's go GA, that's at the surface, over GB. And G over GB, GA over GB is big G, big M, over RA squared, which is really the radius of the Earth. And then that's divided by big G, big M, over RB squared. And the G's and the M's cancel, and that's RB over RA squared. All right, that's nice. And so these values, GA and GB, you have in your problem. So what we're looking for is the height above the surface. And let's note that the height is equal to the entire, this radius of Earth is really my radius A, so let's just clarify that here. All right, so the height above the surface is equal to, and this is RB as well. So the height above the surface is RB, this whole thing, minus RA. That's what we're looking for, RB minus RA. And so now we know this fraction, and it's RB over RA squared. So let's go ahead and really we want to solve for, let's solve for RB. So if we square root both sides, we get RB over RA is equal to the square root of GA over GB. Again, you know these values. So RB is equal to RA, square root of GA over GB. There we go. That's what RB is. And now bring this idea down, the fact that H is RB minus RA, and you get H is equal to, all right, RB is RA, square root of GA over GB, and then minus RA, so minus RA. And that's just simply equal to RA factors out, square root of GA over GB, minus 1. That's your H. There it is. Now you might have found that to be more cumbersome than just going with GB as GM over R squared, solving for R, knowing what the value of GB is. In any case, you have to subtract off, well, you'd have to subtract off from this radius that you find the radius of Earth, which is RA. So here it is, and I kind of like this form because we didn't have to know the universal gravitational constant and the mass of the Earth canceled out, but you do still need to know the radius A. Of course, it's given to you. It's given to you at 6.371 times 10 to the third kilometers. And these are given in the problem as well. The gravitational field at the surface, gravitational field at the new location. So there is your solution.